Have you ever stopped and wondered how a massive, sprawling city actually works? Well, today we're going to pull back the curtain on its digital nervous system. It's this incredible unseen network of eyes and brains that, believe it or not, keeps our entire world running. So let's get right into it. I want you to imagine something for a second. What if your city wasn't just concrete and steel, but was more like a living thing? What if it could literally see what's happening on every street and it had a brain to understand it all? Now, this isn't science fiction. This is the reality of how our cities are being managed right now. You know, the easiest way to wrap your head around all this is to think of it as two separate but connected parts. First, you've got the city's eyes, which are constantly gathering information. And then you have its brain, which makes sense of everything those eyes are seeing. Let's see how they work together.
So here it is, the core of the whole system. On one side, you've got the eyes. This is remote sensing. Think satellites, think drones. They're up there collecting just massive amounts of data. And on the other side, you've got the brain. That's GIS, or Geographic Information Systems. This is the seriously powerful software that takes all that raw data and turns it into actual usable intelligence.
Okay, so let's start with the eyes. How in the world does a city actually see everything from way up in the sky?
The technical term for it is remote sensing, and it's pretty much what it sounds like. It's the science of understanding our world from a distance. We use these super advanced sensors on satellites and drones to see exactly what's happening on the ground, but without ever having to physically touch it.
But here's the thing, not all seeing is the same. The quality of this vision, it really depends on three different kinds of resolution. You can think of these as the different ways the eyes can focus, how clearly they can see, how often they look, and even what kinds of light they can perceive.
So let's break that down. First up is spatial resolution. This just answers the question, how much detail can we actually see? Is it sharp enough to spot a single car in a parking lot? Next, there's temporal resolution. This one's all about time. How often can we look at the exact same spot to monitor, say, how fast a new building is going up? And finally, you have spectral resolution. This is the real superpower. It lets us see in wavelengths the human eye can't, like using infrared to tell the difference between a healthy green park and a patch of artificial turf.
Now, one of the most advanced eyes in this whole toolkit is something called LiDAR. It's pretty cool. Instead of just taking a flat picture, LiDAR shoots out millions of tiny laser pulses and then measures how long it takes for them to bounce back. And the result? An incredibly precise, unbelievably detailed 3D model of the landscape. And this isn't just some abstract theory. This is happening on the ground right now. In Delhi, for example, they're using LiDAR drones to create these hyper-detailed 3D maps. This kind of precision is absolutely crucial for the enormous task of regularizing unauthorized colonies. I mean, it's a job that would be practically impossible otherwise. It's a perfect example of these eyes solving massive real-world urban challenges. Okay, so the city has its eyes, and they're collecting these endless streams of data. But all that data is pretty meaningless without a brain to process it all. And that's where GIS comes in. So the GIS brain organizes information in two main ways. You've got vector data, which thinks in terms of distinct objects, a point for a tree, a line for a road, or a polygon for a park. But then you have raster data, which thinks in surfaces, kind of like the grid of pixels in a photograph. It's perfect for things that are continuous, like elevation, temperature, or those satellite images we were just talking about. So once the data is all organized, the GIS brain can actually start, well, thinking. It uses these specific analytical tools to answer really complex questions, turning all that raw data into intelligence we can actually use. Let's take a look at some of its signature moves. First up, we have something called buffering. Basically, it's like drawing a digital boundary or corridor around a feature. A perfect real-world example of this is transit-oriented development. Planners can ask the GIS brain to instantly show them every single property that falls within, say, 500 meters of a metro line. It's fast, it's accurate, and it's incredibly powerful for making policy decisions. Next up is overlay analysis. And this is where the real genius happens. The brain can take different digital maps, or layers, and stack them right on top of each other. So you want to find the absolute best place for a new housing project? It's simple. You just overlay the land use map with the soil type map and the flood risk map and the road network map. And boom, you can find the one spot that checks all the boxes. And finally, there's network analysis. This is all about finding the most efficient path from point A to point B. It's the same logic that Google Maps uses, but for the city.
It calculates the fastest route for a fire truck to reach an emergency, avoiding traffic and one-way streets. Or it helps planners design the most logical and efficient new bus route. Now, what's really amazing is that this technology isn't just being used by individual cities. In India, it's being scaled up into this massive, coordinated national effort. It's like a team-up of digital eyes and brains on a nationwide scale. Two major platforms are really leading the charge here. First, there's Bhuvan, which is ISRO's own powerful geo-platform. It's used to monitor huge projects. And then you have PM Gati Shakti, which is this incredibly ambitious master plan designed to coordinate literally every piece of infrastructure being built across the entire country. And just to give you a sense of the scale we're talking about here, the PM Gati Shakti platform integrates over 200 different GIS layers from all the various ministries. I mean, just picture that. More than 200 digital maps, all layered together, all talking to each other. It's wild. So what does this actually prevent in the real world? Well, it's about avoiding this exact kind of headache. A planner can see exactly where their new sewer line is planned, and they can also see that the gas authority is planning to put a pipe in the exact same spot a year later. This integrated system prevents absolute chaos. It saves millions of dollars and countless hours by making sure we don't have to dig up the same road 5 times. So when you put all of this together, the eyes in the sky and this powerful analytical brain on the ground, it just fundamentally changes how we build and manage our cities. It changes everything. The big takeaway here is a huge shift from being reactive to being proactive. Instead of just fixing problems after they happen, cities can now monitor development as it happens, in real time. Planners can simulate the traffic impact of a new flyover before a single brick is even laid, and our infrastructure gets built smarter and faster. This truly is the digital nervous system for the cities of tomorrow. And that kind of leaves us with one final big thought. We've seen how a city can see with remote sensing and think with GIS. But the next frontier is prediction. So what happens when this powerful nervous system can do more than just see and think? What happens when it can anticipate traffic jams, predict urban growth, or foresee infrastructure failures before they even happen? That's the future these technologies are building for us today.